Hello. Hello. Okay, fine. See, see the first question. The first question. We are having the three rods. Okay, from the same material, having the same cross-sectional area, form the sides of isosceles triangle ABC. Right angle at B. Right angle at B. Okay. The points A and B are maintained at temperature T and root 2T, respectively. Respectively. In steady state, the temperature of point C is Tc, assuming that heat conduction takes place along the length of the rods. Okay. We are having an isosceles right angle triangle. Okay. Like this. Right angle is at B. Right angle is at B. I can say that the length of AB and length of BC are same. Okay. And all the three rods are made up of same material. So thermal conductivity will be the same, such that temperature at A it is T and temperature at B it is root 2T. Temperature at C it is Tc. Okay. Heat will conduct along the length of the rods. We need to find the ratio Tc by T. Okay, na? Fine. Okay. We know that it is rate of heat transfer. Okay. That is Q by T along BC is equal to Q by T along CA. Along CA. Let us consider heat is transferred from A to B, sorry, B to C and then C to A. Okay. So suppose whenever it is BC, I can write KA. Heat will be transferred from high temperature to low temperature. So it will be root 2T minus Tc by L equal to along CA, KA, T minus Tc, sorry, Tc minus T by L from C to A. Right? Is it fine? So root 2T minus Tc is equal to, okay, Tc minus T, length of AC, can I say it is root 2L? Because length of AB is L and BC is L. So it will be root 2L. Okay. So upon calculation, we'll get as root 2 Tc equal to Tc minus T. Okay. So 3T equal to root 2 plus 1 times Tc. So correspondingly, Tc by T equal to 3 by root 2 plus 1. Right? Is it fine? Okay, now that is option B. Okay. Okay. Next. Completed. Huh? Okay. Next question. The resistance of the following circuit in the circuit diagram between A and B. We need to find the resistance of the circuit between A and B. Okay. First, in the Wheatstone bridge, I can say that bridge is balanced. Bridge is balanced. Okay. So there will be no current will flow in the galvanometer resistance. That is between E and F. So equivalent resistance in the Wheatstone bridge, I can say these two resistors. Okay. In the upper branch, it will be in the series. So we'll get 4 ohm. And similarly, lower branch also in series. Both the 4 ohm are in parallel. So we'll get equivalent resistance in the Wheatstone bridge will be 2 ohms. Right? Fine. Huh? Okay. Nah? Is it okay? And then next it is, you can see we are having the this resistance, suppose R1, R2, and R3. All the three resistors are in series. So we can say it is 6 ohm. It is in 6 ohm. Now, these 2 ohm and 6 ohm are in parallel. So, equivalent resistance will be 6 into 2 by 6 plus 2. That is 12 by 8, approximately 3 by 2 ohm. Okay, na? That is option A. Okay, na? Write down. Fine, na? Okay, fine. Na? Can I go to next question? Next one. It is a traveling nucleus A having de Broglie wavelength lambda A spontaneously splits into two nuclei B and C of equal masses. After the split, B travels in the same direction while C travels in the opposite direction with a speed half of the B. That means speed of C, it is in opposite direction, and with respect to magnitude, it is half of the speed of B. Okay. Okay, na? Fine. The values of de Broglie wavelength lambda B and lambda C we need to find. So initially nucleus A is splits into B and C. Okay. Let us consider initially the mass of A as M. B and C. Okay. We are having masses as m by 2 and m by 2. Okay, na? Is it fine? Okay. By applying conservation of momentum, suppose initially it moves with an velocity u. Okay, travels in the same direction. Okay. B is moving with V1 and C is moving with V2. V2 they gave. Okay, na? Fine. So I can say that mu equal to m by 2 into V1. Since C is moving in opposite direction, that is, I'll write minus m by 2 into speed of C, it is Vb by 2. So Vm by 2. Okay. Upon cancellation or cross multiply, that is 2mu equal to m times V1 minus mv1 by 2. So 2mu equal to mv1 by 2. So v1 equal to 4u. Okay, na? Fine, na? Okay, na? 4u. Since lambda equal to h by mv, so lambda b equal to h by mass of b is m by 2 and it is v1. v1 is the speed of b. So 4 times u. Okay. So h by 2mu. Lambda a equal to, lambda a means h by mu. h by mu. So I can say it is lambda b equal to lambda a by 2. Okay. Similarly, lambda c equal to h by mass of c is m by 2 and speed of c means v1 by 2. Okay. So v1 by 2 means 2u. That is nothing but lambda a. So it is lambda a by 2 comma lambda a. That is option B. Okay, na? If you have any doubts, you can post. Or if you want to repeat, you send message. Okay? I'll respond. Fine, na? Next, fourth one. A solution containing, okay, active cobalt atomic number 27 and with mass number 60 has an activity that is 0.8 microcurie. Okay. And decay constant lambda is injected in animal's body. When 1 centimeter blood is drawn, that is volume of blood, it is 1 centimeter cube from the animal body after 10 hours of injection. The activity is found to be, initial activity is 0.8 and thereafter it is found to be 300 decays per minute. Total volume of the blood in the animal's body. Okay, na? Total volume of blood in the animal's body we need to find. Fine, na? Since we know that activity A equal to A naught times e power minus lambda t. Okay. Fine. Okay. Suppose, let us consider we are having an activity of volume, so and so volume. Let us consider it as X. So that means we are having for A naught, we are having a volume V. For X volume, V centimeter cube, we are having activity as A naught. For X centimeter cube, what will be the activity? So it is A dash equal to A naught by V into X. We can say A dash or A1. Okay, na? Fine. So correspondingly, volume equal to X times A naught by A1 times e power minus lambda t. Okay. Initial volume, they gave it as 1 centimeter cube. Okay. 1 curie equal to 3.7 into 10 power 10 decays per second. Decays per second. Here, activity is 300 TPM, decays per minute. So we'll convert it. Okay. So 0.8 into 10 power minus 6 into 1 curie. That is 3.7 into 10 power minus 10 divided by, okay, 300 dpm. So 300 by 60 into e power minus lambda t. Okay. E power minus lambda. Here they gave the time now. Okay. E power minus lambda t, direct value they gave, that is 0.84. 0.84. Upon calculation, we will get the volume as, that is 4.97 into 10 power minus 3 meter cube. So it is nothing but 4.97 liter, or approximately I can say it is 5 liters. Okay, na? Okay, na? Is it fine? Okay, na? Okay. Can I go to next question? Okay, fine. Next one it is, when a ceiling fan is switched off, when a ceiling fan is switched off, angular velocity reduces to 50% of its initial value. Suppose initial angular velocity is omega naught. Now it is reduces to 50%. That is nothing but omega naught by 2. Okay. Now, while it makes 36 rotations, number of rotations is 36. Angular retardation of the fan is uniform. Angular retardation means we can write as minus alpha. How many number of rotations will it make? Okay. Suppose let us consider n dash before coming to rest. Before coming to rest. Okay. So initially we know that omega square minus omega naught square equal to 2 alpha theta. Okay. that is omega naught by 2 whole square minus omega naught square equal to 2 alpha. Initially, they gave the 36 rotations, right? So, theta equal to 2n pi. Okay. So, 2 into 36 into pi. So, it is minus 3 omega naught square by 4 equal to 2 alpha times 72 by pi. So, alpha equal to minus omega naught square by 24 into 2 means 48. 48 into 4, approximately 192. Okay, na? Now they are asking that how many rotations will it make before coming to rest? Before coming to rest. That means here final velocity, whatever final velocity is there, now it becomes initial velocity. Right? Before coming to rest means final velocity will be 0. So it is 0 square minus omega naught square by 4 equal to 2 alpha theta dash. I need to find number of rotations. Okay, na? Fine, na? Okay. So minus omega naught square by 4 equal to 2 into alpha means minus omega naught square by 192 pi into theta dash means I'll write as 2 n dash into pi or 2 pi n dash. Okay. So upon calculation, okay, we'll get as 1 by 8 equal to n dash by 96. So n dash equal to 12. Right? Is it fine? Okay, na? Write down. Okay, na? Is it fine? Can we go to next question? Okay. Fine. Can we go to next question? Next one. It is. The next question it is. Sixth one. A particle is projected from the ground. Okay. A particle is projected from the ground and simultaneously a wedge starts moving towards the right as shown in the diagram. As shown in the diagram. The maximum height of the wedge for which particle will not hit the wedge. Okay. Particle will not hit the wedge. Okay. Fine. Fine. Okay, you can see sixth question. First it is, this is the ground ma. We are having the wedge at an angle 53 degrees. Wedge is moving with, okay, 1 meter per second. Okay, here we are having a particle, okay, it is projected with 10 meter per second at an angle 53 degrees, which is at a distance 1 meter. Okay, fine. Is it okay? Okay. What we should find? Maximum height of the wedge for which particle will not hit the wedge. Okay, fine. That is, this maximum height we should find. So firstly, this is, let us consider u. I am resolving it. Okay, this is my ux and uy. So ux equal to u cos 53 and uy equal to u sin 53. Ux equal to u cos 53 and uy equal to u sin 53. Right? So 10 into cos 53 means I can write it as 3 by 5. That is nothing but 6 meter per second. And here it is 10 into 4 by 5. That is 8 meter per second. Okay, na? Fine. Okay. Along the x direction, along in this direction, distance traveled. Okay. S equal to, can I say ux into t? So ux means 6. So distance traveled it is 60. Already here we are having a distance as 1. Okay. Distance it is 1. Okay. Fine. So we can say that it is, and wedge is moving with 1 meter per second. So it is 60 equal to, this distance it is 1. Wedge is moving with velocity 1 meter per second. So 1 into t plus, okay. Let us consider this length of hypotenuse as r. Okay. So along in this path means x component means r cos 53. That is phi t equal to 1 plus r into 3 by 5. Okay, na? R times 3 by 5. Fine, na? Along x direction. Similarly, along y direction, I'll find. Okay, Sy equal to, okay, Sy equal to uy into t plus half ay into t square. Uy means it is 8. Since it is projected up, ay equal to minus g, that is minus 10. So minus 5t square. Okay, so 8t minus 5t square equal to, okay, that is initial velocity is 0 along vertical component. So it is r into sine 53. R sine 53 means, which we can write it as 4r by 5. 8t minus 5t square. Okay, fine. Upon calculation, okay, this is, let us consider it as second equation and it is first equation. Squaring and adding. Okay, 3r by 5 and 4r by 5 will get r square. Okay. And here, upon calculation, we'll get as x equal to 35 by 9 meters. Okay. So height it is h equal to, okay, h is equal to r into 4 by 5. That is 4 by 5 into 35 by 9. That is 28 by 9. 28 by 9 meters. Right? Fine. Fine. See, that means in this question they are asking the maximum height at which particle will not hit the edge. So firstly, I am finding the distances along x-axis and along y-axis. Right? Fine. Once go through. Okay, na? Can we go to next question? Next, seventh one, it is a square loop EFGH. Okay, a square loop EFGH of side A, mass M and total resistance R is falling under gravity in a region of transverse magnetic field B equal to B naught Y by A, where B naught is a positive constant. Okay, na? Fine. B equal to B naught Y by A. Y is the position of side. Whenever they gave the diagram, observe the diagram. Here, I can say that external magnetic field, they gave cross. That means external magnetic field is acting inwards. Okay, now, if at some instant, the speed of the loop is V, then the total Lorentz force they are asking. Okay. Firstly, you can see motional EMF. Okay. Motional EMF. Okay. Motional EMF in the EF and FG, it is 0 because it is parallel to OX and OY. Okay. So motional EMF along E1, that is motional along EF will be BLV, that is B into A into V. That is, okay, na? B into A into V. Okay. That is B naught Y by A times AV. Okay. That is B naught Y into V. Similarly, I'll find motional EMF along GH. Okay. Here, GH it is side, it is A. So, we'll write it as B naught times Y plus A by A times AV. Okay. So it is B naught Y plus A into V. Okay, na? Okay. Now, in the EF, you can see in the EF, okay, as it is moving, current is moving towards right, okay, and even in the GH, it is opposite in direction, okay, towards G, this is E, this is F, and it is G, it is H, E2, this is GH, induced EMF in the EF, okay, na? Since it is in opposite direction, net induced EMF will be opposite, that is B naught into Y plus A into V minus B naught YV. That is nothing but B naught A into V. While deciding the net induced EMF, these polarities plays a vital role. We need to understand here the vital role of the polarities. Okay, that decides the direction of the induced EMF. So, induced current I equal to E by R. That is nothing but B naught AV by R. Okay. So, correspondingly, force along EF. Okay. Force means I can write it as BLV. Okay. BLV. So, or we can write as BIL. B means B along EF, it is B naught Y by A. L into current B naught AV by R. So, B naught square A square Y by R into A into V. Similarly, force along GH. Force along GH. We can write as B naught square A into Y plus A into V by R. A will get cancelled. Here also A will get cancelled. So we'll have B naught square AY by R. Okay. Okay. Fine. And force along GH, it will be in the upward direction. By applying the right hand thumb rule, I can say it is upward direction and EF will be in the downward direction. So net force will be B naught square A square V by R. That is, I got it as net force as force along GH minus force along EF. That is B naught square A square V by R. Okay, na? That is B naught square A square V by R means that is option C. Okay, na? Fine, na? Fine, na? Is it okay? Fine. Okay. Can I go to next question? Okay, fine. Next, eighth one. A mixture of two gases, A and B, is kept in a vessel which is maintained at temperature T. In the vessel, there are n molecules, each of mass m, and of the gas A, and 2n molecules. Okay, we are having the two gases A and B. In gas A, we are having n molecules, each of mass m. Gas B, 2n molecules of mass it is 2m. Mean square velocity of the molecules of B is V square. Okay. We can say it is V mean square or V average square. Okay. Fine. And the mean square velocity of gas A along x direction, it is W square. They are asking to find the value of W square by V square. Okay, na? Fine, na? Okay. So, mean kinetic energy of two types of molecules, A and B, it will be the same. Right? In A, we are having the N molecules are there, a mixture of two gases. Right? So, I can say that it is kinetic energy of A will be equal to the kinetic energy of B. Right? Can I say? Okay. Fine. Suppose half M into V square. Okay. I'll write as VA square. That is equal to half into mass of B, it is 2m. Average velocity is V square. Upon calculation, we'll get it as half of will get cancelled. VA square means, okay, particle A, it can move in 3 dimensions now, along x-axis, y-axis and z-axis. So, I can say it is 3 times W square equal to 2V square. So, W square by V square, I can write as 2 by 3. Right? See the option? That is D. Okay, na? Fine, na? Is it okay? Is it fine? Is it fine? Okay. Next question, that is ninth question. Two particles of equal mass m are moving with velocities. Vi cap, suppose V1 bar equal to Vi cap, and another particle it is V by 2 times I cap plus J cap. If the particles collide completely inelastically, then the energy lost in the process. Okay. Energy lost in the process. Okay. In the inelastic collision, momentum will be conserved. Right? Momentum will be conserved. So, we can say that it is M1U1 plus M2U2 equal to M1V1 plus M2V2. Right? Okay. If the particles collide completely inelastically, they give. That means both the particles will move with an, okay, will move with an combined velocity. Okay. Fine. That is completely inelastically. 1 minute. Perfectly inelastically means we can say combined velocity. So it is M1 plus M2 into V1 plus M1 plus M2 into V2. Okay. Initially, two particles are having velocities. Okay. So upon solving, they gave the V1 bar and V2 bar. Okay. That is initial velocities they gave. Initial velocities they gave. Okay. So upon solving, I can say it is both are having equal masses. So U1 bar plus U2 bar equal to 2V1 bar plus 2V2 bar. Okay, na? Fine, na? So V1 equal to 3V by 4 and V2 equal to V by 4. Right? Huh? So change in energy means that is we need to find loss in energy. That is E2 minus E1. E2 minus E1. So E1 is the initial energy which I can write half mv square, that is for first particle, and second particle it is velocity, it is under root v square by 4 into 2. So that is v square by 2. That is nothing but v by root 2. V by root 2 whole square. Okay. That is nothing but initial energy will be mv square by 2 plus mv square by 4. That is nothing but 3mv square by 4. Similarly, final energy will be half into mass is 2m. V1 square it is 9v square by 16. V2 square will be v square by 16. So it is cancel 10mv square by 16, or we can say 5 by 8 mv square. So delta E equal to mv square take common 5 by 8 minus 3 by 4. Okay. That is mv square by 8 into 5 minus 6. Okay. So that is mv square by 8. Option D. Right? Fine. So always, every time, we can expect one question from these collisions. Right? So please concentrate. Please concentrate on the according to your trend analysis. Fine? Right? Can we go to next question? Can I go to next question? Okay, fine. Next, 10th one. A block of 200 kg is being pulled by some men by an inclined plane of inclination 45 degrees, and coefficient of friction as 0.5 as shown in diagram. If each man apply a force of 500 Newton, okay, then the minimum number of men required to just slide the block up the plane is, okay. See the diagram. Firstly, we are having an incline. Okay. Okay. Here we are having a pulley. And to this, we are having a block. This is pulled by a force F. Let us consider. Okay. F equal to 500 Newton. We need to find the how many number of men is required. First, I'll find how much, what will be the total force. Okay. Okay. Whenever the block is pulling, okay, here for the block will have normal force or normal reaction. This normal force is balanced by mg cos theta. Towards the inclined plane, we are having mg sin theta. Okay. From the object, vertically downwards is mg. Fine. Is it okay? Since the block is moving up, so frictional force will be acts downwards. Okay, na? So total force required, I can say it is F dash equal to mg sin theta plus frictional force. Right? That is nothing but mg sin theta. Frictional force means mu times n. That is mu mg cos theta. Okay. So upon calculation, we'll get as force it is 200 into 9.8 times 3 by 2 root 2. 3 by 2 root 2. So number of men required will be F dash by F. F dash by F. That is 200 into 9.8 times 3 by 2 root 2. F it is given as 500. So we'll get it as 4.1 or approximately, okay, upon calculation, we'll get as 4.9. Okay, fine. So in the given options, if you see in the given options, okay, approximately it will be C. Okay, na? Fine. Is it okay? Fine. Okay, fine. Next question. Can I go to next question? Right. Next, 11th one. In a uniform magnetic field of strength, that is magnetic field strength, it is 0.15 Tesla. A short bar magnet of magnetic moment it is 0.32 joule per Tesla. Potential energy of magnet in unstable equilibrium. Potential energy will indicate with U. Okay, na? Okay. Unstable equilibrium means that is when theta equal to 180 degrees. Unstable equilibrium. That means theta equal to 180 degrees. So it is potential energy equal to minus m bar dot b bar. That is minus mb cos 180. Nothing but it is m into b, potential energy. Substitute the values, which will get 0.32 multiplied by 0.15. Okay, around we'll get it as 4.8 into 10 power minus 2 joule. That is first option. Okay, na? Here, I'm saving the time for calculations. Okay, if you want, you can cross check. Okay, fine. Na? Okay, next question. It is the current I1 in ampere flowing through 1 ohm resistor in the given circuit. In the given circuit, they are asking to find the current in the 1 ohm resistor. Okay. Here, net voltage applied is 1 volt. Okay. So, total resistance I'll find. Okay, na? First, current equal to V by R effective. Here it is, since these two 1 ohm parallel, so it will be 0.5. And here it is 2. So, 1 by 2.5. That is nothing but 0.4 ampere. Okay, na? 0.4 ampere. Okay, here it is, resistance divided means, here it is 0.5. So, here current will also become half. So, current in the 1 ohm resistor will be half of the total current because resistance is half and they are in parallel. Right? Huh? So, 0.4 by 2 means it is 0.2 ampere. That is nothing but first option. Right? Huh? Fine. Right on. Okay, na? Fine. Next. See the next one. That is 13th one. Okay. In many situations, to find electric field using Gauss law, we can use the equation E equal to Q enclosed by epsilon naught into A, where epsilon naught is the permittivity of free space and A is the area of Gaussian surface. Q enclosed is net charge. Among the following situations, equation can be used. That is, under what situations we can use this equation they are asking. Okay. So first statement it is only when the Gaussian surface is equipotential. Okay. Only when E is constant on the surface. Only when Gaussian surface is equipotential and E is constant of the surface. Okay. That means on the Gaussian surface, okay, electric field on the Gaussian surface will consider the total charge such that what will happen? It will be equipotential surface because on the surface potential will be constant. Potential will be constant everywhere. Okay. So this Gaussian surface must be equipotential surface and also electric field must be constant. And also electric field must be constant. Right? That is option C. Okay, na? Write down. Right, na? Next, it is 14th one. An inverted bell lying at the bottom of lake. Okay. At the bottom of lake means it is at a depth. Suppose H equal to 47.6 meter deep. Okay. Has volume 50 centimeter cube. Okay. The bell is brought to the surface. That is, it is volume at the bottom. Bell is brought to the surface of the lake. Then the volume trapped air will be. Okay. At the top, what is the volume they are saying? Okay. So in this lake, temperature will be constant. When temperature is constant, we can say that it is P1 V1 equal to P2 V2. That is nothing but pressure at the bottom times volume at the bottom equal to pressure at the top times volume at the top. Okay. Fine. Huh? Okay. Fine. Huh? Okay. So pressure at the bottom, I can say it is P naught plus H rho Z. At the top will have P naught times Vt. Okay. So volume at the top will be 1 plus H rho G by P naught times volume at the bottom. Okay, na? Fine. Na? Okay, they gave all the values. You can substitute the values. So volume at the top will get as approximately 300 centimeter cube. Right? Huh? So it is option B. Okay, na? Fine. Na? You can substitute values. Okay. Next, 15th one. At a certain place, acceleration due to gravity is determined, okay, the length of, determined using a simple pendulum. Length of a pendulum is 25 centimeter. Length it is 25 centimeter. And stopwatch is with the least quantities, that is delta t equal to 1 second. Measures the time taken by the pendulum. Okay, that means for 50 seconds, it had taken 40 oscillations. We can find the time period. They're asking to find accuracy measurement in G. That is, we need to find the delta G by G. Since we know that time period equal to 2 pi into under root L by G. From this, I'll simplify and take logarithm and differentiate it, which will get delta G by G equal to 2 times delta T by T plus delta L by L. That is 2 into 1 by 50 plus 0.1 by 25. Right? So delta G by G into 100, it is approximately 4.4%. Okay, na? Fine. Once see. Once see. Okay, na? Can we go to next question? Right? Can we go to next question? Next, 16th one. A bar of mass m and length L is in pure translation motion with its center of mass moving with a velocity v. See here, this one, this bar. It collides and sticks to another identical bar at rest. Whenever it is moving, it sticks here. Okay. Assuming that after collision, system of two bars becomes one composite bar of length 2L. Like this it came. Composite bar. Then we need to find angular velocity of the composite bar. Okay. Na? According to the conservation of angular momentum, initial angular momentum equal to final angular momentum. This is first bar, this is second bar. Second bar initially it is at rest. Only first bar is moving with a velocity v. Right? Fine. So with respect to center of gravity, since velocity is moving from the center of mass, so we can say mv times L by 2 equal to second rod, it is at rest only. So there will be no angular momentum. Final angular momentum will be, since the total bar is rotating from its center, so it will be ml square by 12. Total mass is 2m and total length it is 2l. So 2l whole square by 12, that is the moment of inertia times omega. Okay. So initial angular momentum, I am using the formula mvr. Final angular momentum, I am using as I omega. Right? Fine. Is it okay? So that is mvl by 2 equal to 8ml square by 12 times omega. Upon calculation, we'll get as 3v by 4l. Okay. This will rotate by applying the right hand thumb rule. Okay. We can get the direction as anti-clockwise. Okay. Fine. Is it okay? That is, see the option, that is option A. Okay. Fine. Next it is 17th one. This is well-known question. Mostly in the PYQ they asked, and in every material we will have. In any coaching institute material we will have. The given diagram shows elliptical orbit of planet of mass m about the sun. T1 is the time taken by the planet from C to D. T2 is the time taken by the planet to move from A to B. Then the relation between T1 and T2. Okay. According to Kepler's second law, we know that it is dA by dt is equal to constant. Suppose if area of SAB equal to A. So in the given question, they gave that condition area of SCD, it is 2A. For SAB, it takes a time as T2. Okay, fine. So A by T2 equal to 2A by T1. Okay. So upon calculation, we'll get the answer. That is T1 equal to 2T2. Okay, na? Fine. Na? Okay. Okay, fine. And next, 18th, the speed of sound in hydrogen gas at NTP it is 1328. Okay. Speed of sound it is 1328 meter per second. Density of hydrogen, that is, I will indicate with rho, 1/16th of that of air, that is density of air. Then the speed of sound in air, they are asking. Generally, speed of sound means we can write it as, okay, under root gamma p by rho. Okay, na? Where gamma is the ratio of specific heats. So speed is, okay, speed is inversely proportional to the density. So speed of air by speed of hydrogen equal to density of hydrogen by density of air. So upon calculation, we'll get as speed of air as 332 meter per second. Okay, na? Fine. That is option B. Fine. Next, 19th one. That is displacement of damped harmonic oscillator is given by, where t is in seconds. Time taken for amplitude to drop to its initial value. Suppose initial value I'll consider as A naught. They're asking time taken to drop to its half the initial amplitude. Okay. This time we need to find. This time we need to find. So we can say that it is A naught by 2 equal to A naught times e power minus 0.1 into t. Right? So e power 0.1 into t equal to 2. Apply ln on both sides. So 0.1 t equal to ln2. ln2 means it is having value 0.693. Okay. So it is, upon calculation, it is approximately 7 seconds. Okay, na? Fine. Is it okay? Fine. And then next one. If an electron in hydrogen atom is in second excited state, orbiting the nucleus in stationary orbit of radius 4.65 angstroms, 4.65 angstroms, then it's de Broglie wavelength. Okay. In the de Broglie, we are having quantization, that is n lambda equal to 2 pi Rn. That is 2 pi R. Okay. Fine. Since here they gave that it is second excited state. Right? So n is equal to 3. 3 lambda equal to 2 pi R. So lambda equal to 2 pi by 3 into radius, that is 4.65 angstroms. So upon calculation, we'll get lambda equal to, okay, 9.7 angstrom. That is option C. Okay, na? Fine, na? Okay, na? Okay. Like this, every day we'll discuss the paper, ma. Okay. For remaining questions in this paper, in this one, okay, you can message me. Okay. If you want, I'll send paper. Okay. Like this, we are having the questions. You can see one is regarding to the magnetism, and almost 3 questions from the optics. Okay. and one question from the capacitors. Okay, I'll message you. Okay, if anyone wants the paper, you message me in my WhatsApp. Okay, and every day we'll have the one paper discussion will be there, full length paper like this. Okay, if you want, you can attend. Okay, na? And you can send your doubts.